Good morning, all. Today we are going to this Fourier transforms. The main application for this Fourier transform is to the solution of some partial differential equations with the boundary conditions can be obtained by help of the Fourier transforms. And also, there are so many applications out there. We are able to hear the sounds of some different types of that sounds. For that, we are able to hear it clearly by the help of the Fourier transforms. Fourier transforms, there are so many applications of that. Now we are going to see about what is Fourier transform, what are the different names of that. From that, what are all that Fourier cosine and the sine transform for that different types of the functions. Now, the Fourier transforms, it's a transformation, if you want to say this clearly. Now, the Fourier transform, or we can say this is called as an infinite Fourier transform, or we call it as a complex Fourier transforms, can be defined as the infinite Fourier transform, or simply the Fourier transform of a real valued function. F of x is defined as f of x. This f represents the Fourier transform. It's a transformation. Okay, this is a transform operator. F of x, which is equals to integral minus infinity to plus infinity f of x e power iux into dx, provided the integral exists. We can denote it, this Fourier transform of this f of x can write it as f of u, or this f cap of u, which can be written as f of u, which is equals to integral minus infinity to plus infinity f of x e power iux into what we get now dx. Now, after that, now what we are going to say from this means now, what you are going to say from this. Now, what about the infinite Fourier transform? The infinite Fourier transform for the function f of u. How we are defining is, which can be written as f of x, which is equals to 1 by 2 pi integral minus infinity to plus infinity f of u e power minus iux into d. You see that the Fourier transform of the function f of x means f of x. The infinite Fourier transform means the same thing, f of x. Now, the inverse Fourier transform means that the f of x, small f of x is equals to 1 by 2 phi integral minus infinity plus infinity f of u e power minus iux into du. Okay. Some of the properties of this Fourier transform, that means that the constant with the function means if you take that constant as outside and applying the Fourier transform for this given particular functions 1. Okay. These are all the simple properties. The change of scale property, that f of x, which is equals to 1 by a into f of 2 by a, and also this is a shifting property. F of x minus a is equals to e power iua into f power of u. Okay, this is a modulation property. These are some of the simple and important properties that will be useful for our future. Okay, let me move on to some of the problems which is related to what is that here. Fourier transform. How can you find out the Fourier transform for the different types of that continuous as well as the discontinuous functions? You see the problem here. To find the complex Fourier transform for the function f of x, which is equals to 1 for mod x is less than or equal to a, 0 for mod x is greater than a. Hence, evaluate integral 0 to infinity sin x by x into dx. Now, you know that the complex Fourier transform or infinite Fourier transform or Fourier transform, everything will be same. F of u is equals to minus infinity to plus infinity f of x e power iux into dx. Now, you see that here the limit is mod x less than or equals to, that means that minus a to plus. Now, in between this minus a to plus a, what is the function value here? 1. 1 into e power iux into dx. You know that integral e power iux means e power iux divided by I. That means that integral e power ax into dx can write it as e power ax divided by a. That means that the coefficient of this x will come to the top. Now you take that 1 by iu as outside, substitute upper limit a and also minus a here, which is in the form of what is that here 2i sine of a. This is by help of the complex numbers. Now I will be cancelled. You will get 2 into sine of a u by u. Okay, that's why the Fourier transform for the function f of x is equals to 1 mod x less than or equal to a can be written as 2 into sine of a u by u. At the same time, integral 0 to infinity sine x by x into dx, that we have to evaluate. Now that for that I am using that infinite Fourier transform f of x 1 by 2 phi minus infinity plus infinity f of u e power minus iux into du, substituting the function f of u here. Now cancelling the 2, take this 1 by pi is already in the outside. Now just compare with that our concept here now. Sin x by x into dx. Sin x by x into dx means here that is sin au by u will be there. In the place of x, that here u will be there. That's why I want to replace that u into x. At the same time, I'm going to substitute what is that here. A is equals to 1 also. What I wanted to say here, just f of x. Put x is equal to 0. I am substituting over that here. If I substitute x is equals to 0 here, what is our f of x function? F of 0 is also 1. That's why f of 0 is equals to 1 now. Now 1 by pi into sine au by u into du, because the left hand side becomes 1. That's what I wanted to say it as clearly. You know that this is an definite integral, minus infinity plus infinity, it as 2 by 2 integral 0 to infinity sine au by u into du. Now just what is that here? This 2 by pi will comes to the left hand side becomes what is that here? Pi by 2. Just now I told you replace u by x. I got what is that here? That's fine. The Fourier transform for the function and also inverse Fourier transform for the functions integral 0 to infinity sine x plus dx becomes pi by 2. At the same time, we are going to see for what is the complex Fourier transform for the function f of x is equals to x plus mod x is less than or equal to alpha, and 0 for mod x is greater than alpha. Writing the formula for Fourier transforms. Substituting mod x less than or equal to alpha. Just I told it in the previous problem, which is minus alpha to plus alpha. This value is x here. Now, this is a u into integral dv. This is here also we are applying the Bernoulli's. I think you are already known about this. Applying the Bernoulli's formula. Now, and I am also substituting the limits over there here. Now I am substituting the upper limit as well as the lower limit. Now here, if you cancel, it will get what is that here? Minus I into alpha by u2 cos alpha u plus 1 by u square 2 I into sine of alpha u. Now this becomes, if you write it as, you will get the Fourier transform for the next function now. Okay, and these are some of the important problems which is related to what is the Fourier transform for this. What is that here? Different types of the functions. Now this is also our important problem now. F of x 1 minus x square mod x less than or equal to 1 and the 0 mod x is greater than 1, and hence find out the Fourier transform for the given two types of the functions. Now this is f of x is given here now. Now this is 1 minus x square, substituting the function 1 minus x square, applying same the Bernoulli's here also. Now what we get here, 1 minus x square u v1 u dash v2 plus u double dash v3. Now applying the Bernoulli's at the same time, everything, if you go to, can you see that e power iu plus e power minus iu becomes, it becomes what is that here? 2 cos u. Understood my point? What is that here? It becomes what is that here? 2 cos u. Now that's why what is that here? This becomes 2 cos u means now here all this is becomes 2 I sine. That we saw it in the last problem. And now at the same time, this becomes 4 by u square, 4 by u cube. These functions we got it. Now applying for the last problem here also we are applying for inverse Fourier transform f of x f of u e power minus I u x into du. Now it becomes 4 into substituting the function. Now here also the same thing here. I want what is that here? E power 0x, because this value becomes, I want it becomes 1. That's why I wanted to share it for what is that here? I wanted to show it for what is that this values. Put what is that here? X is equals to 0. That's why f of 0 becomes 1. Substituting the values. Now here also the same thing. I am simplifying. I got what is that here? Sine u minus u cos u by u cube. This value replace u into x. I got is that what is that here? Replace u by x. I got is that here minus pi by 4. I got it. And to find out the next value now here I got it. What is the next value? For the next value means here also I am taking the same function, the previous function what I took. I'm substituting x is equals to 1 by 2, f of 1 by 2. F of 1 by 2 is, you see the previous problem here, 1 by 2 becomes 1 minus 1 by 2 whole square becomes, it becomes what is that here? 3 by 4. Now substituting the values, left hand side becomes 3 by 4, just cross multiply. After you cross multiply, you just compare only the real parts. If you compare only the real parts, you'll get cos function as well as this function inside. Cos function, you'll get what is that here? You'll get 3 pi by 8 becomes minus 3 pi by divided what is that here? 16. Okay, like that. Here I am solving for what is the Fourier transform for the different types of the functions. Also, I apply the inverse Fourier transform for that. Like that, we are going to find out. We are able to find out the Fourier transform for the different types of the functions. Okay. Yes. Thank you. For the next class, we are going to see about, for the next video, we are going to see about what is the Fourier transform for sine and the cosine transforms. Understood? Thank you all.